Good evening, everybody, and welcome to this month's WWDC Lightning Talks. As I said, it's been a little while since we've been together, but glad to see everybody again. Glad to finally have a meetup happen. I think we're actually starting to get a little bit of a buffer, so we'll actually have a little more come through the end of the year. But as we said, let's go ahead and get started. So welcome. So there's actually been one change to the agenda today. We actually have 7 talks, not 6. So, in order, first I will start off with a traditional what's new in Xcode. Then Matt will talk about building a UIKit app with the new design. Russell will go into a quick overview on foundation models, followed by a deeper dive from David. Sean will be talking about improving memory usage and performance within Swift. Danny will be talking about what's new in SFSymbols. And then finally, Andrew will wrap us up with talking about UI automation in Xcode. That's the announcements. We'll come back to that. So with that, let me switch my screen and we will go ahead and get started.
Is Ed trying to get his stand goal?
Yeah.
A giant head.
All right. And first off, let's talk about everyone's favorite or least favorite, depending on your day, developer tool, Xcode. As you can see, right off the bat, one thing that's new is we have a nice shiny icon, thanks to the whole UI design and liquid glass redesign. They're finally giving Xcode a little bit of a facelift, which makes my Basil Rules Xcode project shirt now a little bit out of date. So unless, maybe we can tell someone at BasilCon this year to actually make a new logo. So if you want to tell Bradley that.
Yep.
But let's actually talk about, there's actually quite a lot of new that's coming out in Xcode this year for the better. First off, size and optimization benefits. It's going to be about 24% smaller to download because Apple's finally come to the point where we're saying bye-bye Intel. We have basically 1 more year left of Intel and then we'll be kind of gone. So there's no more Rosetta support by default. And they only download the Metal toolchain if you need it. And then kind of using Xcode, we get a lot of benefits. It's 40% faster to load workspaces, and it's up to 50% improvement in text input latency when using complex expressions. I don't know if you all deal with it, but compiler type inferring a complex expression is a message I see all the time. I think obviously where some of the bigger stuff we're going to see is really with smarter workflows and editing. Intuitive editor tabs. There's now a new start page for your tabs. You can also start pinning your tabs to specific files for better organization. Search is starting to become a little bit more user-friendly. There's a multiple word search, which uses the search engine techniques to find word clusters across documents and source files. And you can find those terms in any order, spanning multiple lines, and even sorted by relevance, showing that they're actually taking a much more deeper look into actually seeing how they can search and pull results back to you. I won't be surprised if there's a little bit of foundation models at play there, and I'm sure people will talk about that a little later. A really interesting use case, voice control, Swift mode for voice control. So you can actually write Swift code naturally using voice commands, and it will understand your Swift syntax, such as spaces, camel casing, and operators. And then kind of expanding upon the benefits we've seen over the years from Swift playgrounds, there's now actually a playground macro, which will actually allow you to essentially use playgrounds within Xcode. So allowing you to inline code experimentation with live results in a dedicated Canvas tab. And it also makes it great for understanding existing code and prototyping new ideas. This means it's also open source for other platforms. Asset and resource management, obviously we talked a little bit about the new icon and how that ties into the design system. In order to actually build your new icons in the new design system, there's the Icon Composer app. It allows you to create sophisticated multi-layered icons within a single file. It supports multiple platforms and in duck and tinted mode. It supports iOS, iPadOS, and macOS, and the new watchOS look. Supposedly it doesn't actually support visionOS, and apparently I've heard people say they grumbled about that, but it was a shrug and it just doesn't work for visionOS right now. And it leverages material effects such as blur, shadow, and translucency to help really make your icons pop out. And then for within your Xcode, using your string catalogs, there have been a lot of enhancements to string catalogs. They now also contain type-safe Swift symbols for localized strings, allowing you to access things using Swift syntax and not just try to have to use the keys to find things. You can define strings directly in the catalog with autocomplete. And then there's also now automatic context-aware comment generation for translators, again, using the on-device foundation models. This is probably really the thing we've all been waiting for, is the code intelligence and AI integration. Obviously, the biggest thing is Swift Assist is finally coming, except Swift Assist is probably no longer what we really thought it was. So there is the large language model integration, which allows you to ask general specific Swift questions, use context within your code to ask project-specific questions, then even have Xcode make changes on your behalf. Tied into this is also the coding tools menu, which offers a lighter weight menu for quick actions on selected code, as well as allows for custom queries in the text field. Through this, there's smart context control. Your models understand your project context, looking at symbols, files, issues within your project, kind of taking that cohesive view of your project to understand what's happening. You can also attach files to give it greater context, like having UI sketches and using that to generate code. Then you can also control the project from context inclusion and automatic code application. So that way, if you don't want it to kind of understand that context, you can tell it not to. Modification history, it will actually take a snapshot of your code before each change for easy review and unwinding. And then issue fixing, you can generate a fix option for errors and allow it to have to map your protocol performance and deprecation warnings. Model provider options, by default, it's enabled with ChatGPT, a specific limit. It comes with a free account limited request, or you can also bring your own account. But kind of where Apple is starting to also deviate a bit is you can actually integrate other providers, such as Anthropic, if you have the API keys. And then you can also just tell it to purely only use your local models, such as Olama and LM Studio. Kind of tying into something we'll talk about a little later, but there's also a greater emphasis on debugging and performance tools. Just using debugging, the Swift concurrency has gotten a lot of improvements on its ability to be debugged. It can actually follow execution into asynchronous functions and even jump across threads. You can display the task IDs in the backtrace as well as in the program counter. And then just through the debugger, there's clearer representations of task groups and actors and the variables. It's kind of really allowing you to see where all these concurrent actions are happening. There's a fix for missing message usage description. Xcode will actually identify these missing usage descriptions for private resources, and you can actually now add them directly into the signing and capabilities editor, and automatically adds the capability into the definitions. And then finally, with instruments, there's a few new tools and updates. There's a new processor trace tool, which has high fidelity CPU execution analysis on Apple Silicon, and it captures every branch function call. CPU counters, it has new preset modes such as checking for bottlenecks or instruction characteristics, as well as having some microarchitecture optimization. And there's a newer next generation of the Swift UI instrument, which actually has detailed cause and effect analysis on Swift UI view updates for performance optimization. And then there's a power profiler, which actually allows you to record and visualize power metrics for energy and impact analysis, and it can do this both tethered and passively. And I know that's actually something Apple's starting to take greater care of. Myself and a few others went to a workshop on this last year at Apple HQ, so this is something that actually really starting to turn a big eye to. Then app monitoring and build system changes. There's trending insights in the Xcode organizer. It's expanded to hang and launch diagnostics as well as to disk write. They now have flame icon highlights to highlight issues that are trending in the wrong direction in case if something's changing. The charts now show an increase across the last 5 app versions, and there's also now URL sharing for diagnostic reports. And also now Xcode Organizer can compare app metrics against similar apps and historical data, and it gives you clear performance targets that you should think about trying to hit. On the build system side, explicitly build modules is now enabled by default. It was previously just enabled for C and Objective-C. This does improve build efficiency, reliability, and debugger speed when everything is hooked up correctly. I know for a fact when it's not hooked up, then your project just won't compile. Explicit modules is the future, but it's still going to take some people some time to get there. Swift Build has now been open source. This was honestly a huge thing. I think getting to see the build system now really being open source and having that visibility into it. The community can contribute to the build engine that now powers Xcode and Swift. It has support for Linux, Windows, Android, and more within Swift Package Manager. And I think under the hood now they're starting to use more of the Swift build system directly in Xcode with Xcode 26. There's also some enhanced security capabilities that provides Apple level protections like point authentication, which you can start enabling, and it's recommended for apps that have significant attack surfaces. And then some of these we'll talk about a little later too. There's also been a lot of testing advancements. There's a new UI automation recording. It adds new code generation system for UI tests that allows Xcode to generate concise code with multiple identifier options during the recording process. It's integrated into the test reports automation explorer with the video recording. Allows you to inspect identifiable elements after failure to get the correct code snippets. And there's better device support for hardware interactions, such as dealing with keyboards and buttons. On performance testing, there's a new XCT hitch metric, which is a new API which can actually allow you to catch UI hitching, such as scrolling during performance tests. It allows you to report metrics such as the hitch time ratio, like a hitch time ratio. And then finally, in test plans, there's now the ability to have runtime API checks, which allows you to surface framework runtime issues and threading problems using the thread performance checker. It allows you to detect if there are any queues that are having priority inversions, and if there's non-UI work on the main thread, then it actually allows you to fail these tests if we find issues. In conclusion, Xcode 26 is going to deliver significant improvements across the board. It's going to be more efficient, more intelligent, more performant, and lead to higher quality with more robust testing and build system and security. All right. Any questions?
Question.
Yeah.
I'm seeing contradiction information. It can Xcode 26 can run on Sequoia and earlier machines. How much of these features are turned off if you don't have Tahoe or an M processor?
I think it's mostly just the LLM and like the smart code assistant.
Nothing else other than the LM.
Yeah, I think everything else will be available, like the icon composer, all the testing advancements. Like a lot of that will still be available. I think generally anything specifically tied to the Swift Assist system that needs foundation models will be locked to Tahoe only. All right. If not, then thank you everyone, and I'll hand it over to Mac.
Okay. Thanks, Scott. Today I'm talking about building a UIKit app in the new design. So in case you didn't know, new this year, Apple has redesigned their operating systems. They're calling the new design system Liquid Glass. It is a new material, and the idea here is that they revised the overall structure of your user interface, adding this new glass material in between your app's content and controls. So the easiest way to think about it is that anything liquid glass exists primarily or only really in the control layer. The video here is showing you some examples. So the scope of this talk, there is a corresponding adopting liquid glass in your Swift UI app talk, and everything I say here applies also in Swift UI. The APIs are slightly different. I called out a couple of them, but the focus of this one is primarily UIKit adoption. So the way that this talk was structured in this year's conference was by component largely. So the focus here is on tab and navigation split view. The corresponding UIKit controls are UI tab bar controller and UI split view controller. There are some new things happening here in tab bars. This video is illustrating what's going on in the Apple Music app on iOS 26. You'll notice a couple of new things. So there's this new glass appearance, which is the material I mentioned existing between the content of the music app and the control layer. these buttons in the tab bar. Additionally, you'll notice that there is this new expanding and collapsing behavior that you can optionally enable in your own app if you're using tab view or UI tab bar controller and tab bar. There's a new API for tabs, for tab bars, and that is the accessory view. And that's what we're seeing here. So if you have something like now playing control for music or podcasts, you could do something like that. You see here in the Apple Music app. And then additionally, you may have seen previously on iPadOS last year, Apple gave us the special UI search tab and the tab with the search role in SwiftUI, and that now becomes similar to its last year's iPadOS counterpart on iPhone. And there's some additional changes for search views on iPhones as well. So the code for that is pretty straightforward. There's a new tab bar minimize behavior on tab bar controller, and a corresponding tab view that's just scroll down. You can also specify on scroll up. There's an automatic option as well. So depending on if your content is aligned towards the bottom, maybe like in Maps is the example, or I guess traditionally if you have sort of like a news feed or something like that, when you scroll down the content, the bar collapses, and then on reverse it expands. And then it handles the animation nicely for you. You saw with the tab accessory view and the corresponding search tab if you implement one. So then here is the API for that. Now playing an accessory example that we saw, it's the tab bar controller's bottom accessory. And SwiftUI is shown above the tab view bottom accessory, which is in view. There are some new traits as well that have been added to the UIKit side for that. So if you needed to expand your content for the space available in this talk, we also saw some examples of how to do that. But mostly it's a response to traits in UIKit. Here's an example of split view new this year in split views. If you're using UI split view controller, you may be used to the content kind of being squished visually when you expand. But new this year is this visual effect that they're applying in iOS 26 or in their 26 version of their operating system. And the visual effect is such that the content is meant to extend underneath. So this visual effect is you have the glass, that's the control layer with the sidebar, it appears over your content. And they've given us some new APIs to achieve that effect while maintaining alignment for the safe area with respect to content with text content that you might place in there. The expand and collapse behavior, if you're adopting UI tab, it's more or less automatic. You see here across macOS, iPad, and iOS the appearance of the navigation split view or the UI split view controller, or if you're using tab bar controller and using UI tab. In this example here, they have a poster image. That's the one we're seeing behind the sidebar. And this background extension view in a UIKit app is how you achieve the content of that image to extend into this area behind the split view, behind the sidebar. And so you that's background extension effect. So if you're curious about like what does that mean or how does that really any different than last year, this is sort of the difference. So you can disable it if you still prefer this look, but if you didn't, this is kind of what you end up with in the new liquid glass appearance. The sidebar kind of floats independently and over the front. What's new in navigation and toolbars? Navigation items have been rethought a little bit, so it's hopefully coming across there. It's a little hard to see, but there's a new automatic grouping if you're using UI navigation items. So by default, when you link against the 26 SDK, UI navigation items are going to be grouped according to their role. If you have UI navigation items with images, those are grouped together, and that means that they share a glass background. They're part of the same class effect group. And then system items like done and cancel, those are also grouped independently and together. And then there's a new prominent style that is grouped separately. And I think on the next slide, there's an example of that. If you want to influence that, Apple's guidance here is to use spacing items. There's a new toolbar spacer in Swift UI, and then the flexible space and fixed space, or the fixed space item and UIKit to separate them. Here's the code and an example of the prominent style item. And you can see kind of that grouping behavior that I mentioned here. And if you need to influence it, to use the fixed space, which is some new things in navigation item title area. So we've had large title, but they've made that a little bit more open to us app developers using it. So it now supports a subtitle. I don't think that's shown here, unfortunately, sorry. But you can imagine below the line space for subtitle now. And now they both support attributed string, which I'm happy about because previously had to resort to using a UI label and a custom view with the navigation item if you want any sort of attributed text there besides the attributes that you specify for the entire string. And then as well, we get custom views like we have for the standard center of UI navigation item title view that extends to subtitle as well. Some examples of that. Large subtitle view, attributed title. Scroll effects. So this is how Apple's referring to this new visual effect that applies to top and bottom bars over content. Primarily, if you have a navigation bar or a toolbar over a scroll view, you're getting this scroll edge effect, and you can influence that depending on what you need for your application. In this example, we're seeing that there is this new UI interaction. And so a UI interaction for this container that contains some buttons over a scroll view. So you may have some buttons like this that are sort of always visible. The content scrolls with the edge effect where there is this blur, vibrancy and blur effect applying to the scroll view. And you can apply this to your own custom views by using the UI scroll edge element container interaction and specifying the edge. You can also opt out of it. So in the calendar app on iOS 26, you can see that there's this opaque top bar, and where we have the date view at the top, the top edge effect style is hard, can be soft or automatic. But in this example, we're seeing the soft effect. Can try to choose automatically what's best, but in cases you need to intervene, like this one, you can specify that the scroll edge effect is hard, and that will give you this opaque appearance where it does not apply the blur on scroll. Presentations are new. If you're using UI menu, this is more or less automatic, what you saw at the initial part of the video. And the idea is that the source item now like morphs into the presented thing. So like you can kind of see how I tap the button and then the menu sort of morphs out of the button that I tapped. They've improved the zoom animation, so you can specify the source item to improve that transition where the item kind of morphs into the presented thing. We're also seeing the sheet, which has a performance presentation. It's a little bit narrower. It includes the sort of glass background, or I guess the absence of a background and the glass material. Apple has rethought search for iPhone. So now they're specifying in the HIG that search bars really belong on the bottom, sort of like we've been seeing in Safari for a while. If you're using UI tab API or the tab view with tab and roll, and you specify search, this is kind of what Apple has in mind and what you get out of the box. So Apple's thinking like search is a dedicated experience, and then by default you kind of tap on a phone and launch into that. Apple's updated all of its main controls. So here's some examples. With segmented control with slider, with button, there's an UI button configuration. And the glass effect mostly applies during the interaction, and then it fades away when the user stops interacting with it. They also have new dimensions. So when you link against a new SDK, one thing you certainly need to do is audit for anywhere that you might have layout concerns with respect to controls that you've placed that have grown in size. For custom components, Apple's given us some new APIs as well. They've given us the glass effect and glass container effect. And the primary difference is that glass container effect is if you have multiple views that you want to share a glass effect. So if you think about the navigation bar example, you have multiple items, you want them to share a glass background, you'd use glass container effect. If you have a single view, glass effect works. And it's better for performance, Apple says as well, to use the glass container effect for multiple views sharing glass background than single views within a glass. That's my lightning talk.
We know when we, without making any changes in the app, and we put it on the new iOS 26,
Okay.
does these glass effects come into effect?
Yes, they do. So by default, when you link against the new SDK or you use Xcode 26, you will get the new glass design. Apple has given us a new info plist key. So if you want to use the new SDK, you're not required to adopt the new design. You can take your time with that and then move to the new toolchain. And that entry effectively disables the new design until you're ready. And in the talk, Apple says like at least a year of support, and at some point it will be required. So you can expect after a couple of years, it probably won't work anymore, and like you'll have to do that work. But I imagine most of us have to like talk with our designers and decide what's right for our app. Do we want this? You know, where do we want this, and how do we want to rectify like our existing design with glass? All of that stuff. So we have plenty of time to do it. So by default, if you just open up your project in the new Xcode and run it, you're going to see liquid glass applying to all of the system controls. And that's really great because, you know, they've done a lot of the work for you, especially if you're using some of these navigation components like navigation view, navigation bar, navigation controller, tab bar.
Yeah, because our app is completely tab bar, right? So
Yeah.
What happens if it's running on a device on an older OS? It's good to finally.
So if you compile your app with the new tool chain, but it's running on an older OS, the new design does not, there's no liquid glass that's like backported to iOS 18, 17, 16.
You mentioned a lot about UIKit, but only once or twice you mentioned the app kit for the Mac OS. Is there a lot of additions to Mac OS as much? Some of us still write Mac OS software.
You know, Apple didn't give a talk about using liquid glass.
I noticed that.
Yeah. I think they call that a Swift UI app these days.
Mac,
Yes.
you mentioned getting the search behavior with the UI search bar. Do you happen to know if you also get that if you're still using the old school UI tab bar item and use the search system behavior? Or is that left as a...
So in UIKit, there is a new API that Apple gave us last year.
Yeah.
It is UI tab. So previously tab bar controller tabs were derived from its children, its child view controllers and their corresponding tab bar item. Now there is UI tab, which is effectively a model for a tab, which is takes a name and an icon and then a closure that returns a view controller. And once you adopt that, you get that, like on iPad OS, you get this adaptable sidebar behavior. But there is a special subclass of tab or a corresponding, they call it role, just like a default role and a search role. So there's only really one special case of UI tab, and that is UI search tab. And when you do that, it becomes detached. It's sort of like in this trailing group, Apple calls it. There's a leading and a trailing group. I don't think we have any leading examples yet, but it could be the case in the future. But on iPad OS last year with a search tab, you got this trailing it sort of separate from the main group of tabs. And then they're kind of bringing that to iOS this year. So it requires you to at least adopt UI tab.
Thanks.
But it is, I think that API is available in last year. What is that, 17?
18.
I'm really glad that they're giving us 26. It's easy to remember now, 27. Yeah, last year. Any other questions? Oh, hey.
I guess. What's your personal opinion on transparency being everywhere now?
I know that there's a lot of feedback about it, and Apple's in beta 3 has refined it further, and now it's like less glassy and more just a blur. So I think that the accessibility concerns, one thing I'll say is that they seem to be paying a lot of attention to accessibility with this. So you'll notice with each iteration, accessibility becomes more aggressive in disabling some of the effects of glass. And I think that's really great. And you can see that they're paying a lot of attention. So anyone who's saying like, it's a terrible decision and Apple's going to totally abandon it, I think probably is or like, I don't agree with that. I think Apple's going to get there with it. They just have to refine it further. But Apple says also, I mean, since day one said in their public docs, don't use it everywhere. It's not meant for everywhere. It's meant for the control layer. And really the whole reason behind the design is to give more room and more focus to your content. So really you should think critically about like, what is your app's content, you know, that you want to showcase. And then what they're going to do is make sure that their navigation layer kind of like gets out of the way of your content form when it can. All right, then next is Russell.
All right. Good evening, y'all. Let me pick this out. Unless I hear otherwise from y'all, I'm going to assume that y'all can hear me.
Yeah, you're good, Russell.
All right, excellent. Well, so I want, howdy, Russell Mirabelli. I'm dialing in from Dallas. And so the howdy is not an affectation at all. And I wanted to have a chance to talk about the foundation models, because next to liquid glass, this was one of the most exciting things for me. So first of all, though, before we get started, I wanted to define some terms, right? What are foundation models? Well, foundation models is an API introduced at WWDC. It's an on-device LLM built into the operating system. Okay. So, and that's available in all of the 26 OSs except for Watch and TV, and only on the 15 Pro and similar hardware levels of phone, right? So it's not all devices all the time, everywhere, but the big thing is it's built into the OS and it's on device. It has a size, the LLM has a size of 3 billion tokens. Now, the thing that you want to know when you hear that number, 3 billion tokens, a typical server-side LLM, like the ones that we're more accustomed to dealing with, if you've been using LLMs, is 100 billion tokens. So the size of the LLM is significantly smaller. However, the fact that it's running on device is awesome. But before we talk about going into a deep dive into how the foundation models API works, I wanted to mention playgrounds. This was a new feature in Xcode 26. I'm glad that I don't have to talk about what version of what is what. It's all 26 now. That's great. Okay, so here we go. We've got a screenshot of playgrounds where on the right we can see, well, you can see I just did a hash playground with body and then entered some nonsense Swift in there. And you can see over in the right, the playground just running. I don't have to have a separate playground project anymore. That's awesome. It's great to experiment with and so on. You're going to see a whole bunch of screenshots like this in this talk because, man, I love this. Okay, cool. So the way that foundation models works, we create sessions and then we wait for responses from the sessions. Now, I originally tried to do some LLM work using some Hugging Face models several years ago using MLKit. I don't know if anyone else, had this experience, but there was I think it was 2 years ago, we got the ability to import models into MLKit fairly easily, but I had a real hard time getting anything meaningful out of it. Maybe I never got anything meaningful out of it at all. It was complicated, never quite worked right, but the new session is as easy as it gets. So here we go with the playground. I just have a session. I create a let session equals language model session. Let response equals what's the average daily temperature in Colorado, and then print the response. And then over in the right, you can see, well, we created a session. We got a response. Took 10.5 seconds to get a response. This is running on device. This was running on my M1 Air laptop, my personal laptop. Okay. And then you see we got a response. And hey, look, it tells us back our prompt. It says how long it took, and it gives the content. And wow, look at all that text with all that stuff. That's kind of useless. Okay, but it gets better. Don't worry. So we can also do cool things like once we start up a session, we can do we can make multiple queries inside that session. For example, we can do a for loop over various places and do normal Swift syntax things to put in some variable substitution. We can check out different responses in a single run through our playground. And you can see we can actually look at each of the responses show up separately in the playground. And wow, look at those times, 26 seconds, 14 seconds. That's not even that 10 seconds from before where it wasn't so bad. Now it's even worse with 26, 14, and these are all running serially, right? So, whoa, that's great. Okay, but we couldn't hand these to the user, right? You look at that response and you can't hand that to the user. So the problem with most LLM created content is making it all make sense. And if you've ever worked with an LLM before to try to do something interesting, you might have given it some sample JSON, hoping that it would match the formatting and output your content in that JSON format. And good luck with that. Sometimes it works, but I've done this, and I get random formatting of data from multiple LLMs, and which means you have to deal with decoding errors, and it'll concatenate first name and last name, even though you said, give me a first name field and a last name field. All kinds of awful stuff like that. Passes off numbers and strings instead of numbers. All the kinds of things that could go wrong with decoding information. Well, it gets even worse when you get an LLM involved. So what do we have? We have @Generable now, and this is truly outstanding. I don't say that often about very many things. This is the new @Codable. This is such an excellent macro. It automatically formats the output from the foundation models into coherent output. Now, coherent meaning that the data is in the correct format, not necessarily vouching for the content of the content. And it supports all the plain data types you'd expect, and it's composable. So any generables that go inside a generable, it all works. It's turtles all the way down. And yes, generable is a real word. Okay. So a note about generables and about foundation models in general, you're going to see this next screenshot. Our time to generate goes down significantly because we've given it more context than when we were asking for a plain text response. This is awesome. Fields are generated sequentially. So another note, fields are generated sequentially. The response to one element in your structure can influence subsequent elements in your structure. So it matters the order in which your fields are set up in a generable struct. Units of measure does matter. And remember, again, the models are baked into the OS. It has no knowledge of events. And this also really matters. Your responses are going to change with every release of the OS. Okay, because data will have changed, the probabilities will change, all that kind of stuff. But does it create good data? Okay, now I've changed the response, and now I've asked it to give it to me in this generable format. And I said, give me a title to go along with that temperature. And now look at those durations, 2.7 seconds, 2.5 seconds. Those are actually coherent, reasonable. We can deal with these kinds of times. Provide the title and temperature for the destination Colorado. Provide a title and destination for California. And we see, oh, hey, look, exploring the diverse climates of California, the serene temperatures of Vermont. Those really want me to go on a vacation somewhere. I'm in Texas where it is, we're barking on the door, we're barking at 100 degrees, and this still doesn't get me wanting to go to these places. So what we want to do is we want to provide some assistance with @guide inside the generable. So rather than just giving the names of things, we actually provide like a smaller chunklet of prompt that will be filled out using the guide. So we say vacation destination, we have a location. What is the location for it? Give me a suitable title for an adventure vacation at the location and the average daily temperature in July in degrees Fahrenheit. Okay. And then look at that. Explore the diverse wonders of California. That is actually really good. And 85 degrees, 82 degrees, experience the heart of America in Ohio, that famous vacation destination. So pretty cool. We're really starting to get somewhere here. We can see that the foundation models are actually starting to give us something cool. Okay. In fact, we can even simplify the prompt because the guide provides the context. Look, all I have to do is provide with my prompt now is provide a title for an exciting vacation in place. And because in Generable, I have this information about the temperature, it'll add that in and do that generation without it being in the overall prompt. And that is starting to become outstanding. And we can start to see these are starting to become really interesting vacation names. So we can build a travel app with this, I guess. So how about we use this to feed a travel app and provide like airfare information? And this is one of the inevitable problems with LLMs, right? So we're going to take this away from just getting some general vacation advice, and we want to make an actual travel app. But, how do we get airfare out of an LLM? And especially one that's local. How can we get good information about airfare? What does airfare even mean? Okay, so what we want to do is we want to create some tools for the LLM to use. And tools can be called by the model to gather information at runtime, produce side effects or whatever. And tool calling allows the model to call our code to incorporate up-to-date information. Recent events, actual data, call our useful APIs on top of the LLM generated stuff. So we define tools with a name and a description, and that the framework puts that into the prompt to let the model decide when and how to call our tool. Tools receive arguments and return tool output, which is usually generated content. Okay, that's a bunch of nonsense, but let's see what the tool looks like. It says it's got a name, get airfare, description, retrieve the airfare to location, and then we have some arguments. It gets a location that it's going to retrieve airfare for. And then on a call, we just spit out an integer, right? I mean, I'm creating a phony API here. There's no reason to overthink it, but we can see how this could be. We could insert actual data calls and make something meaningful. So that's cool. Now we update our vacation destination and include the airfare to get to the location. Let airfare. Then inside of our session, we say language model session with tools, and then we provide an array of tools. And the only tool that we're giving it right now is the airfare tool. And so we say, again, await session respond to what's the daily temperature in place, because it's going to do its thing, right? And then we can see, provide an exciting title for a vacation, right? Adventures, 75 degrees, 1, 2, 3, 4, 1, 2, 3. Hey, look at that. It's getting back the airfare for every one of these. It's going into our tool. That suddenly is a useful skeleton for building a framework with an LLM. That is pretty darn cool. But let's talk about using these tools. In my experience, my real experience, even though it's very limited, working with foundation models, sometimes the model is going to use the tool, sometimes it's not. And it can vary between runs of the program. On the previous slide, you saw, hey, it called out 1, 2, 3, 4 every time. Yeah, it doesn't always do that. Sometimes it does, sometimes it doesn't. I haven't figured out exactly why sometimes it does, sometimes it doesn't. But we can have a good chance of enforcing the use of that through instructions. Instructions take precedence over prompts, and they persist for the entire duration of the session. And even things like capitalizing words in the instructions can help. So for example, now alongside the tools, I provide instructions. You must only, and by the way, I've capitalized this before and it really helps, must only use the airfare tool for pricing. And then I said, all titles must be alliterated. And so you can see now it alliterates all the titles, which is fun, but more importantly, it continues to only use the airfare tool. And like I said, this varies between runs of the tool, and so my screenshots always had it going to the airfare tool, but trust me, it doesn't always unless you start going into things like using instructions. So for now, more than anything else, this is something that we can have fun with. How much this is useful for shipping projects, I don't know. Let's be real. But we can do some real things. And we can even provide some, fun things like, hey, provide 6-line sonnets in iambic pentameter about the destinations. And it'll sort of do something that looks sort of like a 6-line sonnet in iambic pentameter. And that's all that I had about the basics of foundation models with real hands-on examples. I'm happy to answer questions if there are any from the room.
One question here.
Yeah.
Do you happen to look at performance while making concurrent requests to the model?
They've been serial, not concurrent.
Does the responses changes based on the devices since everything is on local?
Yeah, responses change from run to run, not just device to device.
So every run will have a different response?
Yep, you'll get different responses all the time. I've also heard that the foundation models are 2-bit quantized, Ed, and I have no way of knowing if that's true or not. Nor could I explain to you coherently what it means.
Thank you.
That's great. All right, anyone else?
The session talks about something called adaptive trainer. I didn't understand what that was. Foundation model, adaptive trainer. Can you explain that real quick?
I cannot.
Okay. Something Python-ish.
All right, with that, thank you. Next up will be David taking us into a little further of a deep dive on foundation models.
All right. So thank you, Russell, for that amazing introduction on the foundation model. My name is David Castillo, and I'll be doing a deep dive on what we just saw. So these are the topics that I'll be touching today. We're talking about the sessions context window, a little bit of how can we modify the responses generated by a session, and I'll be also going a little bit deep into generable and what else can we do with it. So to start off, let's talk about the context window. So if you guys have worked with LLMs before, this should be a familiar concept. The context window is basically the amount of text that your model can work with. And it's limited, it's a finite amount, and your model can't outgrow the context window. Apple hasn't made an official announcement on the size of the context window, but estimates of people working with it seems to be around 4,096 tokens. Note here, a token is neither a word or a character. A token is estimated to be around 3 to 4 characters. So there's a limitation here. And in the case of Apple's framework, whenever you exceed the context, you are thrown an error. You get the error down there, the exceeded context size, window size. And what goes into a context? Basically everything. On the right, you can see all of the entries. Your session has an entry array with basically all of the history of the things that, or the interaction that you have with your session. So the context window takes into account instructions, prompt responses, tool calls, and tool outputs. So what can we do when we are working with a session and we want to basically have our program outlive the session or have a long-lasting session? So what we usually do is we do some kind of context compression. And the cool thing about the foundation models is that we have an initializer that takes a transcript. So we can initialize a session already with some context in it. So first strategy to roll over your context is simply take the latest, most relevant entries of your context. So we are basically, as you can see in the diagram, we're moving the latest prompts and responses. We also always make sure to move the instructions as is. And as Russell explained, instructions are really important because they take precedence over everything else. And they're really important to avoid prompt injection. And the other more elegant solution is to summarize your context. And if you guys have worked with LLMs, you should know that LLMs are really good at summarizing stuff. So you can use another model session, pass it your transcript, generate a summary, and create your new session. And that's something really cool that you can do. And well, as always, make sure to not include the instructions in the summary because we want to keep the instructions as is. Okay, now let's talk about a little bit about how can you configure the output generated by this session. But before we do, let's take a look at how does the model generate responses. So when generating output, the model does so one token at a time. And for each token, it calculates the probability distribution of all possible next tokens based on its context. And once it has the list of probable tokens, it uses a sampling strategy to pick the one that's going to use for your response. It's important to know that it will not always pick the most probable token, it can pick the next or the third most probable one. And the cool thing about Apple's framework is that we can influence both the way that the probability distribution is calculated and also the sampling strategy that we want the model to use when picking a token from that distribution. So let's talk about the first, about the probability distribution first. In regular LLM lingo, this is usually referred to as the temperature of our model. And for this, we can pass generated options to the session when we are waiting for our response. And this is basically a double value. And the lower the value, the sharper the distribution curve will be. And this will basically favor tokens with high probability, making the result more deterministic or confident. And if you pass a higher value, it will flatten the distribution curve, making like tokens with lower probabilities more probable, making the result more creative or random. So I'd like to further answer something that Abhishek asked on the last talk. One way where that you could make your model be more consistent across devices is to, for example, use a lower temperature. And if you want to be more consistent, you can also affect the sampling. So Apple gives us 3 different sampling strategies. The first one is greedy. With greedy, the model will always choose the most likely token. So this, I think that regardless of temperature, when using greedy, you will get the most deterministic model that you can get. So if consistency is important for your use case and you want to make sure that you're always getting the same types of responses regarding your device, use greedy. If not, there are 2 random sampling strategies. The first is stop, that will basically pick the next token from the top X tokens of the list. This in regular LLM lingo is usually known as top K sampling. And you can also do top P or nucleus sampling with random probability threshold, which will, instead of picking from the top of the list, it will pick among the tokens whose probabilities sums up to a certain value that you define. With the 2, you're of course adding like randomness to your responses. But out of the 2, usually the top P or random probability threshold results in a more natural feeling to your model. So if you want your model to feel more human-like, it's usually useful to go with random probability threshold. And that's actually the default sampling when you don't customize anything for your model. All right, let's talk about constraint encoding. So as Russell showed us earlier, we have the generable macro to be able to generate structured output from a model. And how does this macro work in the background? They use something called constraint encoding. And the way this works is whenever the model goes and generates the probability distribution for the next token, it will start masking out invalid tokens according to the constraints that you're given it. So in here on the right, we have an example. We want to generate this MPC object, which has a name, a copy order. And as the model starts generating the response, and when it goes to generate the key for one of the values of our object, you can see that in the beginning it was going to use first name, last name. The constraint encoding framework on the background will start removing those possibilities out of the options. So the model in the end will pick the correct token. And the cool thing is that we can add additional constraints. So Russell already showed us a way to do it, and it's with guide. And he showed us an example using guide with natural language to constrain the value. But there are additional ways to constrain them. So here you can see that we can use ranges. We can use count for the number of elements we want in an array. We can, of course, also constrain the types of our arrays. So there's a lot of things that we can do to get the exact types of responses that we need. And another cool thing about the schemas generated by the general macro is that you can also create them dynamically at runtime. So if your use case needs to adapt based on user input or another value known at runtime, you can do so using dynamic generation schema. This is something really cool about Apple's framework, and it's something called snapshot streaming. So if you guys have used LLMs before, you should be accustomed to like the feeling of the model typing out the response for you. LLMs usually stream responses. That's something called delta streaming. And the issue with delta streaming is that it's not really ideal for structured output. Because, for example, if you're asking your model to give you a JSON, you won't be able to parse your JSON until you have all of the response. So you're going to have to wait for the model to stop generating a response in order to continue. And as you saw from Russell's example, the models will sometimes take really long to give you a response. So it'd be cool if we could like start giving the user some kind of feedback while the model is generating the response. And this is where snapshot streaming comes in. So with snapshot streaming, you are getting a stream of partial objects as the model is generating your response. So as you can see on the right, in this example, we're generating an itinerary object. And one of the things that we get with the general macro is a partially generated version of your object. And a partially generated is basically a copy of your object with all of its properties as optional values. And as you can see on the right, as the model starts generating its output, for example, in the beginning, it will give us an empty object. Then it will give us an object with a piece of the name. Then it will give us an object with more pieces of the name. Then it will give us an object with the name and the array. And then it will start filling up the array. So this is really cool because with this, we can start basically updating our UI as the model starts generating our response. And well, this should be able, it's something really cool to work around those large delays that Russell showed. Finally, a couple of points I wanted to touch about tools. If you noticed from Russell's demo, when he passed the tool to the session, he passed an instance of the tool. And what this means is that we can use state in our tools. And this can be really useful to, for example, cache responses or to avoid repeated responses. But of course, you have to be careful when using a stateful tool because your model can call your tools multiple times in a single session request. And when it does so, it will call them in parallel. So if you have a stateful tool, of course, you're going to have to make sure to protect your state from multiple calls from different sources. And that's my lightning talk. I'm open for any questions in the room.
What is tokens? We heard a lot about tokens, like 3 billion tokens and 4096, the numbers. What is actually?
So a token is a measurement of text. And it's neither a word nor a character. It's around 3 to 4 characters. So yeah, think about tokens as how big of a text.
Two questions from the Zoom. First one, can a tool call other tools?
A tool can do anything. Like you can put whatever you want inside a tool. You can do an API request. Your tool could call another LLM. And that's something really cool that you could do, because you can have like multiple LLMs specializing in different things. And then you can basically have your LLMs interact between them using tools. And this thing like that opens a lot of possibilities.
And then actually, because I don't know, this one was for you or for Russell. I've heard that the foundation models are too bit quantized. Do you know if that's true?
Yeah, Russell touched on that, and I don't have the answer. But no, that's something that I have to look into.
What does the question mean?
That's
I
a
don't
good
know what the
question.
big quantized is.
I don't either.
Okay, fair enough.
Any other questions?
All right, thank you very much. I'll pass it over to Sean.
Next up will be Sean with improved memory usage and performance.
You guys hear me?
Yep.
Awesome. All right. Good evening. So every year, WWDC Apple give us a topic related to performance and optimization. Last year it was John McCall's Swift performance talk, which was really good. This year is about memory performance, specifically how arrays uses memory, and he gave us a lot of examples how to avoid those common pitfalls. So in this talk, Nate Cook showed several examples on how improper usage of arrays can incur performance cost. He used a image decoder example to illustrate how to use instruments and debug these performance issues. Yeah, so feel free to check out his talk. Give it more hands-on instructions, demonstrations on how to use instruments. The first one is algorithm. Suboptimal algorithms can lead to excessive memory copying. So choosing the right algorithm for the job is pretty important. Second, he talked about using flat mapping, which can be very elegant. You have different flat maps, really easy to read, but that can incur some performance costs because you have to allocate memories for each of the closure. Thirdly, he talked about exclusivity, very much like Rust, borrow checker. Swift also have a way to check, making sure the piece of memory that is being modified is only modified by one owner. So next, you talk about heap and stack. Swift 6.2 introduced a inline array as a data type where a predefined size collection can be created on the stack. This is great because you don't have to worry about the exclusivity. You don't have to worry about the dynamic aspects of it. Lastly, he talked about reference counting. The data type Swift 6.2 introduces is called span type. That basically works with a contiguous chunk of memory. Its lifetime is tied to the scope, which is great. You don't have to worry about using those unsafe pointer methods in the previous versions. So yeah, I think it's important to kind of do a summary of how array works and its characteristics. The first is dynamic. It's dynamic memory allocation. Arrays dynamically allocate and deallocate memory based on element counts. Elements are stored in a separate heap allocation rather than inline on the stack. The Swift runtime manages the heap memory automatically without having to manually check and do stuff. This enables array to grow and shrink at runtime without predetermined size constraints. Value type semantics, arrays exhibit value type behaviors. Mutations don't affect other copies. When you assign to another variable or pass as a parameter, arrays are create independent copies. This provides isolation between array instances and prevent unintended side effects. Each copy maintains its own state and modification. Third is the copy on write optimization. This is very well known. Swift implements copy on write to optimize memory usage and underlying storage buffer on the heap. So initial copy is shared, underlying storage buffer on the heap. The actual duplication only occurs when one copy is mutated. It's also known as lazy copying. This optimization reduces memory footprint and improves performances for read-only operations. So yeah, I think all the modern languages like Rust are kind of using copy on write because Swift first introduced to the world. Runtime overhead and safety mechanism. The heap allocation part, we already know. The reference counting, Swift using reference counting arc to kind of keep track of how array buffers are shared between different objects. The uniqueness check before the array being mutated. The Swift compiler, how runtime has to check if it's the sole owner of the buffer. Exclusivity enforcement is the Swift using exclusive access during mutation. Most of the time during compile time, Swift will be able to check all the violations, but there are some other scenarios you have to use runtime to check those exclusivities. So yeah, in summary, array leverage heap allocation, reference counting, copy on write, providing dynamic sizing with value semantics. So in this example, you can see that the first read by function, we assign an array, first element of array to a variable called value, then modify the array by calling drop first. Finally, we make a copy when initializing the data object. So that's kind of the key part there. You're making a copy when you're creating a data object, you're assigning to itself. So the better approach will be the second, the bottom example, where you use the edit in place call called pop first, which returns the first byte and then shrink the array that way. So this negates the need to create a data object and avoid the memory copying. And this example is talking about allocation, excessive allocation. Like I mentioned earlier, these chain closure calls or flat maps are really, really cool looking. They're really easy to read, but each one of these closures, you have to allocate memories for them. So the TLDR is that sometimes it's good to using the good old for loop to allocate all the memory up front and then work with the data you have and then output one time. So yeah. Exclusivity check. So what is exclusivity? So Swift memory safety rule is like only one part of your code can be modified a piece of memory at a time. This is preventing data races and memory corruption. It is very similar to how database works, like preventing two users from editing the same record simultaneously. So why do we need to check them? The compiler can catch most of them during compile time through the static analysis, but in some situations, such as the dynamic array indices, closures that capture variables, protocol types that and dynamic dispatch calls, recursive function calls. All these examples are kind of like really powerful features of Swift, but that kind of have to be checked during the runtime. So what happens during a runtime check? So Swift maintain a runtime register of like active memory access, very much like this example you see here is like variable numbers. You give a 1, 2, 3, 4, 5, and then Swift inject these like invisible tracking code, like begin access and end access. So during that time, if anybody else trying to access it, it will basically be a violation. So runtime exclusivity checks are kind of like Swift safety net for scenarios where the Swift compiler cannot predict. That ensures your arrays are never corrupted by simultaneous modifications at the cost of minimal runtime overhead. So in the example that he showed in the talk, he basically convert or refactored some of the class object into the struct of value semantics. So you don't have to be checking during the runtime because class objects are allocated on a heap, and there are a lot of exclusivity checks if you're using the class type. Heap and stack. So Swift 6.2, like I said earlier, inline array was introduced. This is a fixed size. As you can see, the first generic parameter. While you can make changes to the elements of the inline array, you cannot append, remove, or assign an inline array to a different size. As you can see the example here, it's okay to modify the first element before, but then if you wanted to do append, the compiler give you errors like, hey, we don't have this method for this type. Or if you want to assign this to another bigger inline array, it will give you error. This is good. The use case is pretty limited, I think, because most of the time you want to share your array between different objects. I think this is really useful for like embedded programming or server-side Swift. So lastly, he talked about reference counting. Reference counting and unsafe pointers, it is kind of worth to ask, why are pointers unsafe, right? I mean, there are many, many reasons, I think, but the most apparent reason we all know is like the first is uninitialized memory access. Unsafe pointers can point to a memory that hasn't been properly initialized with value. So reading from an uninitialized memory can return a garbage data that was previously stored at that location. That leads to pretty unpredictable behaviors. The second biggest challenge for the pointers is like the lifetime management issues. Swift automatically manages for you using arc, right? It keeps tracks the sharing of the pointer, but if you're using unsafe pointers, you don't have that arc capability. So you have to manually ensure the pointed memory remains valid for the entire duration or lifetime of the pointer. Other things like reference to move memories, dangling pointers, buffer overflows, it just list goes on and on. So to help with this, Swift 6.2 introduced a new group of types called spans. Spans are a new way to work with contiguous memory belong to a collection. Most importantly, spans uses this new thing called non-escapable language feature, which allows the compiler to tie their lifetime to the collection that provides them. So the memory that a span provides access is guaranteed to live as long as the span. As you can see the example here, you cannot return a span because if you return an object, the lifetime is not guaranteed, right? If you want to wrap this into a closure, like return a closure span.count, it will also give you the errors, the lifetime dependent variable span escapes the scope. Yeah, so this is good. I think this is great for if you work with binary decoding decoders. This is a great data type to use because you don't have to sprinkle unsafe pointers all over the places. As you can see, this is the kind of like the example that he gives. Previously, you had to use with unsafe buffer pointer and blah, blah, blah. And then now you can have this process using span. Very elegant, very nice to read. And you don't have to worry about anything because the lifetime is tied to this closure, the scope. So in summary, we kind of understanding the array's characteristics, the dynamic natures of it, the value semantics, the copy on write. So be sure to check your algorithm, like the function you're calling. Always prefer the edit in place to avoid unnecessary copying. Flat map is cool. It looks really cool, but you might incur some excessive allocations. Just be aware of that. Class types can be a good abstraction, but it will cost you a little bit of runtime exclusivity checks. I think it's really minimal, but it's there. Swift 6.2 new types such as inline array and span can help with problems mentioned above. So yeah, so here's are some references. The first one is the talk from WWDC. The second talk is actually from last year by John McCall, Swift performance. And this is a really good video about how memory performance in the closures and actors are working. Definitely highly recommend that. Yeah, I think that's it. Any questions?
Okay, thank you, everybody. Okay. Next up, we have Danny presenting what's new in SFSymbols.
Yeah, that's So we're going to be talking about what's new with SFSymbols this year. Since WWDC happened last month, there's a lot of cool stuff that happened. So a little bit about me. My name's Danny, been doing iOS since around 2020, since like the dawn of SwiftUI. I make an app called Judy. It's a sheet music reader for iPad. And when I'm not doing that, hanging out with my dog, Charlie, and playing music out and about. So what's new with SFSymbols? This year we have SFSymbols 7. So the headlining feature, I'd say, is the new draw effect. So there's a new animation effect when the symbols are coming on and off the screen. It kind of reminds me of like the Marauders map from Harry Potter. Things just kind of get drawn on. So we'll see a few examples of that. There's a new update for the SFSymbols 7 app for Mac with a lot of cool features to help you build custom draw effects. And there's a few other features, like there's some changes to the magic replace content transition, as well as really nice symbol gradients that you can use. So first up, we'll see a few draw effects in action. So here's the first one. This is scribble.variable. So it's really nice. It just kind of paints itself onto the screen like a paintbrush. And this is rainbow, and symmetrical icons like this, typically they'll kind of like radiate out like bidirectionally from the center. And this is a little bit more custom, where I have like two symbols layered on top of each other. The background is a heart.fill, and then the top one kind of outlines itself, draws itself as an outline there. So let's look at some code. Here I have a signature SF symbol. So we take a look at that. It just draws itself like pen to paper. And this is using, of course, the draw on effect, symbol effect. And it's using a playback option called by layer. And what by layer does, I'll just replay that, is it offsets each layer in terms of the timing. So it'll play each layer with a slight offset, which creates a really nice look. You can also control like the speed and whether it's on or off the screen is active. And this is how you do the same thing in UIKit or AppKit, for example. And in this case, you just have to tell it, just draw on or draw off at the right time. So we'll go a little bit more in depth into the draw effect playback options. So we already saw a by layer, which is the default, but there's also individually, which will just play each layer one at a time. So we'll wait for the first one to finish, then do the second one and the third one individually. I probably should have slowed this down. It's a little bit, a little subtle at 1.0 speed. There's also a poll, so it'll just play all the layers at the same time. And then this kind of confused me for a while. There's a draw off effect, which is for Swift UI, it's very, very similar to draw on. And I thought it was kind of different, but it's almost the same from what I can tell, except the draw off effect also has, gives you the ability to use the reversed playback option. And with reversed, when it goes off the screen, it'll just undraw itself in the opposite direction, which is awesome. Next, you can actually control this draw effect with variable values. So this is really great if you have like a progress double from like 0 to 1, and you want to be able to like control, for example, like the fill in this thermometer. And I actually have it changing, transitioning colors as well as it goes above and below 0.5. But you can, I'm just controlling this with a slider, so you can really have this match with the animation exactly like based on the state. And here I have the variable value control in the back in a Z stack, and then in the foreground I'm actually adding a check mark with this standard draw on effect. So definitely like mix and match and play around with this, because you can create like, you can put multiple effects together and create something really cool. So here, like this is all based off of the same double state. So as soon as it gets to 1.0, it'll actually draw on. And if I was to move the slider back to 0.5, let's say, it would just draw off the check mark. It's really cool. So here's the code for this. It's really simple. This is Swift UI. So all you have to do is add the variable value parameter to the image. And then basically you have to add this symbol variable value mode and specify that you want to use the draw. The reason why you have to specify draw in this case for the value mode is that there's also another value mode called color. And you may have already seen this in the past with like a Wi-Fi symbol where only certain layers are filled in. That would be color. But for something like progress, draw is a really great fit. And here's how you do this in UIKit or AppKit. A little biased, can't tell. Where's Swift UI? So now we'll talk about what's new with the SFSymbols app for Mac. So one of the big things you can do now with this update for Mac is you can actually add this draw effect to your own custom symbols. Or if there's a symbol that Apple has in the collection, and you just want to like change it a little bit or have like one layer go in the opposite direction, you can actually customize that. So they give you like a really nice GUI to be able to like change the guide points and say, oh, I want this to go from left to right. I want this layer to go bidirectionally. So this is the 2D icon SF symbol. So in this video, you can see that I'm kind of like making the draw effect for the music stand symbol. And I'm starting the center, setting guide points, and I'm setting one on each end. I'm kind of guiding it. You can see the arrows are starting to realize, oh, okay, so they want bidirectionally. And you kind of just like trace the way you want it to draw. And then you basically do this layer by layer. And at the end, or while you're doing this, you can actually preview it as you go. It's just the play button. This is all within the SFSymbols for a Mac app. Also, there's over 300 new symbols, and it's just growing every year. I added some that I'd like to call out because, well, there's a lot of music ones, which definitely appeal to me. There's also a bunch of new airplane ones and Apple products like Finder and earbuds, different capsule enclosures that are new. So a lot of cool things. And another really cool thing with this is if you want these new symbols to support, if you support like, you have to support like 16 or 17 or like an older minimum version, it's really easy to have these, like out of the box, they just won't show up. But if you want to use a new symbol for like an older version, basically what you would do is duplicate it as a custom symbol and then export as SVG, and you can literally drag that into your assets catalog and just call it just like any other image. And because all of this annotation data is like inside the SVG itself, you should have be able to use any of these SF symbol features depending on what version the user is using. So wrapping up, there's a couple more features I want to share with you. So one is magic replace. So of course we already have magic replace for content transitions going between one symbol and another. But the cool thing about this year is that Apple has it so that it actually is able to recognize enclosures. So if the symbol A and symbol B have the same like circle or rounded rectangle enclosure, it'll actually figure that out and only update the contents. So here's like an example of it transitioning between trash can and checkmark. And you'll also notice that it's actually utilizing the draw effect within that magic replace. Here's an example going between plus and X. And here's an example where it actually doesn't work. This is a new symbol this year, the calendar symbols. So I noticed that this doesn't work. I created a radar for this. So hopefully as the summer goes on, there's more compatibility for this. So to wrap up, there's also a way to, there's a rendering mode for gradients now. So it allows you to have like standardize the gradients for your icons and creates really nice like a gradient color that kind of allows your icons to pop a little bit, give a little bit more depth. So here's just kind of a little slideshow of some of the ones that I thought were kind of cool with gradients. Thank you. If anybody has any questions, you can ask me now or later. Yeah.
I have a question.
Go first.
So what's the difference between a SF symbol and a font? Let's say I want to use some of the symbols in a terminal-based editor. Can I use the SF symbol?
What was the first thing you said? You said what's the difference between an SF symbol and a what?
And a font typography.
Yes, a font is like a glyph that is like a specialized format for that. Like when you actually go into Font Book, you'll see that it's a separate format, and the glyphs are actually embedded within that font file. You can extract that symbol using, I think it's an open source program called FontForge. It'll actually allow you to extract that vector into like an actual SVG, but SF symbols are just SVGs. So as long as you get it into an SVG, you can add any annotations you want to have it support those SF symbol features. And the SF Symbols app for Mac is really great for I love GUIs, so like it allows you to just add those annotations really easily to the GUI. Yeah.
Thank you.
That new app, does that support the backwards compatible with like anything before the current one? Tau?
Yes, so it's interesting. I have the beta SF Symbols app, and it's I saw like the new updates came out this week, like beta 3, and I was like, okay, did SF Symbols app for Mac update? Like I couldn't tell. I guess I could have downloaded it and checked the build number, but it's so yeah, it is backwards compatible, but I think they're gonna like add some more. They're gonna keep like updating it. So like the features that they added are kind of like I would say like separate. They're kind of like draw effect is like a different toggle. So yeah. Yeah.
Are these symbols that you can use in development, or are these symbols that like you can use on your Mac?
So technically,
I don't know what these are basically.
Oh yeah. So SF symbols are just basically like icons that you can use in your app. I think they came out around like 2019. And every year, so it basically makes it so that you don't have to be a designer to have all these great icons. And also it standardizes the icons that Apple uses so that third-party developers can also use like the same symbols. And every year they just add like more and more animations and features and effects and stuff.
So these are the same icons that Apple uses?
Yeah.
Okay. Can you use these on React Native?
You should be able to because they're just SVGs really, but you may not get the same feature like added SF symbol features that you can access via like the UI frameworks.
Gotcha. Thanks.
Yeah.
Last question from you, then we got a quick.
So with view modifiers like draw, if you're on an older OS, does that just get ignored, or is that a compile time error because hey, this isn't supported?
Yeah, it would be a compile time error. So it would recognize. So they're basically like new view modifiers that only work on like like these ones for the draw ones would only work on like iOS 26. So you can just probably just like backport it or like use like a modify extension or something like that.
Last but not least is Andrew with UI automation.
Okay, hello. Sorry. Okay. So, hello, I'm Andrew. This talk is about UI automation. So, just a little bit of an overview. UI automation mimics the user interactions with an app, and the new thing in Xcode 26 that Scott touched a little bit about is the automatic code gen. So this relies on the app's accessibility features, and generally, the better the accessibility in your app, the better the UI automation will be. So now you want to prepare your app for automation. So just a note, your app can be automated with no code changes. However, there are recommendations in order to make your automation even better. So first, you will add your accessibility identifiers, which can be done manually, or you can have Xcode auto insert those for you. We'll then review your app's accessibility with the accessibility inspector, and just make sure everything's in place and all of your accessibility is what you are expecting. And then you will add a new UI testing target. So now you will record your interactions, and you do need macOS Tahoe for the code gen. And here's a video from WWDC, but I don't think the audio will play. Yeah, I don't.
File for the first time, a popover will appear telling me how I can start a UI recording. Now, I'll start a UI recording using the button in the sidebar, and Xcode will automatically build and relaunch my app in Simulator. Now that my app is launched, I'll go to the Collections view. As I interact with the app, the code representing my interactions is recorded in the source editor. I'll tap the plus button to add a new collection to start planning my own trip to Australia. Now I'll tap the edit button to rename the trip, and I can rename the trip Max's Australian Adventure. Xcode will keep my test up to date as I keep typing. Now I'll edit the collection of landmarks. Just add some Australian landmarks like the Great Barrier Reef and Uluru and tap the check mark. Once I go back to the collections view, I can see that my collection has been added with some Australian landmarks included. You can stop UI recording with the Stop Run button in Xcode.
Okay, go ahead.
Okay, so now that you have your cool UI generated code, you will then review your UI queries, just make sure that everything is what you expect. And Xcode does give you a list of other viable options if you do choose a different one. You'll then add your validations, your XC sort trues, falses, just to make sure your UI is what you expect. And then you can explore other automation APIs like orientation, location, etc. You can then also replay in multiple configurations. So here, just an example, multiple configurations based off localization with different languages. And then finally, review your videos and results. You can see here, the UI test failed in all 4 configurations. And then in the right picture, there's a little red X in the very corner there of where the UI test failed. You can navigate directly to that, see the error, and debug from there. Then any next steps, if anyone is curious on more information. And any questions? Yes.
One of the best uses of AI is the generation of tests using like unit tests and such. Can we use AI once we record it to create the validations and other things? For example, we could use the AI to verify that you're testing all branches of the code.
I haven't tried that, but I would imagine that is possible, yes.
Is this supported on Mac OS too?
On Tahoe.
No, I meant, can you record Mac?
That I also do not know.
Okay. Why do I feel like I'm the only Mac programmer here?
You're not.
What's a long time ago?
Thank you.
We're just about at the end, and by just about, I mean I'm just going to give some announcements, and we'll be out of here. So thank you, everyone. That was a great set of talks. I think we all learned a lot of interesting things. As usual, if you're interested in speaking, reach out to me. I can send you the form. You can just send me a message on Meetup or LinkedIn. Subscribe to our YouTube channel. I think if this actually works, this means we'll actually start getting videos out again. So I'll confirm that once we're done here. But we actually might start getting our videos back up, and maybe I will see if I'm still trying to see what I can do to get our back archive there, but at least our latest videos will be up there. And then we still have our Mastodon and our LinkedIn pages to follow for more of our information. And I forgot to add this back in, but I did find all my stickers. So if you want a sticker, come see me. And if you're a speaker who spoke tonight, I can give you a speaker sticker. With that, thank you for coming tonight, everyone, and I hope you all have a good time. And okay, so next month we will be back here. Our talk will be on the power of Swift UI combined with Swift and functional programming. So we'll be back here second week of August. And now with that officially, thank you all for coming.
Who wants to know what 2-bit quantized means?